Okay, welcome to our first video. So we're going to be doing these from now on. Instead of being in class, this is how I'm going to do problem sessions. So it's important that you get on the discussion boards first and foremost. Any questions that you have in the class or on any problems, ask those questions in the discussion board. Type out the problem, this is the problem, and I mean, to get the best response, maybe show what you've done for the problem and show where you got stuck. That's the best way for anyone to come in and say, this is what I think you need to do next. What isn't helpful is to just say, how do I do this problem? Unless you, of course, have no idea where to start on the problem, then that's fine. But the best discussion starts with, this is the problem and this is what I've done and I don't know what to do next. If you have time to answer questions on the discussion board, that would be great also. The whole point of the discussion board is to start a discussion, of course, about the math problems, about the homework, and having you as students helping each other rather than sending 75 emails to me about, I don't know how to do this and I don't know how to do that, because I will run out of time in my day to answer those kind of questions. So anyway, I've only had a couple of questions. This video is on 3.4 and 3.5. That's the sections that should have been done today, March 24th. I will do those problems, and if you have problems in 3.7 that you should be doing the homework between now and Thursday, please post that in the discussion as well. And again, the first place you should post those questions are in the discussion for that section, and post it to the class, because more likely than not, somebody will know how to do it. And that way, it can be shared on the discussion board. But the problems that were asked of me were in 3.4, number 16. And the question was, use Descartes' rule of signs to determine how many negative zeros and how many positive zeros and how many total zeros are possible in the function p of x equals x to the fourth plus x to the third plus x squared plus x plus 7. Right? So Descartes' rule of signs tells you that if you have the function itself, the number of sign changes is the number of possible positive zeros. So this x to the fourth is positive, the next term is positive, x to the third, positive, positive, positive. So there's no sign changes of the function. And if there's no sign changes, there's no possible positive zeros. This is the ideal situation to find yourself in, because if you have to find all of those zeros, you've already eliminated half of them, right? I don't have to test any positive numbers to see if they'll work here. The other part of this, though, is to test the function evaluated at negative x. So that is to say, p of negative x, which is to replace all of my x's in my original function with negative x. So that's negative x to the fourth plus negative x to the third plus negative x squared plus negative x, and then plus 7. And then simplify. If I have negative x, it's raised to the fourth. Because it's raised to an even power, the negative goes away, and that is x to the fourth. The negative in the third power doesn't go away because it's negative times a negative, which is positive, but then I get multiplied by a third negative, so that stays minus x to the third. The negative on my x squared goes away, so that is plus x squared. And then I have minus x, and then plus 7. So the number of sign changes, my x to the fourth starts as a positive, but my x to the third is negative, that's one sign change. Then I go from that negative to another positive, that's a second sign change, which then goes to a negative, so there's my third sign change. And then across this goes to a plus, so that's 4 total sign changes. So because there's 4 total sign changes when I have negative x input in here, that means that there are 4 possible negative zeros. Or more specifically, 4 possible negative x values in which the function is 0, right? So whenever I get something like that, there's 4 possible negatives. There's always either that number or 2 less, or however many until you get to either 0 or 1, right? So I could have 4, or 2 less than that is 2, or 2 less than that is 0. So my possible negative zeros are either 4, 2, or 0. My possible positives, we said, was 0. So we know that there's 0, so all of our negatives have to be, or all of our zeros have to be negative. Right? So when you're answering the question, it says how many possible negatives could there be? It's either 4, 2, or 0. How many positive zeros could there be? It's 0. It just has to be 0. And then the total, it'll say how many possible total. That's just the number of possible negatives. The very largest one is 4, plus the total of zeros from the positives, that's 0. So in total, I have 4 possible total zeros. That's just by taking the largest of each and adding those together. So hopefully that helps. That's how you look through those guys. I think there's another question in that homework that's similar to this, so hopefully that'll help you through it. Okay. The next one that I had was from 3.5, and that was number 24. And that said, to find all solutions of this equation. And that was x squared plus 6x equals negative 25. There's a few ways that you can do this. If you wanted to, you could add the 25 to the left and use a quadratic formula, or you can complete the square. It's already kind of set up to complete the square, so that's what I'm going to do. I'm going to take half of this middle term, the x term, so 6 divided by 2 is 3. And then if I square that 3, that's 9. That 9 is what I want to add to both sides here. So I'm going to erase this because I feel like I'm going to run out of room. But I want to add 9 to both sides. So then I have x squared plus 6x plus 9 equals negative 25 plus 9. That is negative 16. And on the left, we just completed the square. So this x squared plus 6x plus 9, that's x plus 3 squared. That's what we designed it to be on the left-hand side. The right-hand side is just negative 16. And here, if this weren't negative, we would just square root both sides and we'd be happy and we'd just move on. it is negative, but we can still square root both sides. If I square root the left, square root the right, I just have a square root with a negative under it. And now that we have complex numbers, we can deal with that. On the left, the square and the square root cancel each other, so I'm just left with x plus 3. On the right, whenever I take that square root, there's always the positive or negative, so I have plus or minus square root of negative 16. With the square root of negative 16, I can take that negative out as an I, and then the 16 is a 4. So this is x plus 3 equals plus or minus 4i. And then I can continue to solve simply by subtracting 3 from both sides. So let me write it up here. Maybe, well, let me just build this a little bit. There we go. So then this tells me that I have x equals negative 3 plus or minus 4i, right? And this is the same as having negative 3 plus 4i. Or x equals negative 3 minus 4i. So those are my two solutions. Negative 3 plus 4i and negative 3 minus 4i. So hopefully that gets you on your way. If you have questions again in 3.7, please post those in the discussion. Post them to the class first, see if anybody can answer those. If not, I'll be monitoring those boards. If nobody posts stuff, I'll just post stuff myself for you to answer. But anything that doesn't get answered, I'll end up doing through these videos. So I hope this works out. We had a pretty good session in my 127 class. It seems like it's going to work out well for them. The only thing is that I need you guys to participate. So, be here, watch the videos, let me know if there's things that aren't working, that are working, whatever the case may be. Communication here is key. So thanks, and we will see you guys next time.